Inverse of a rational function is not bad at all.
Go warning. Happy November.
All right. Alright. I forgot I haven't made videos in here very much. I usually don't make them with you guys in the room, but I haven't turned it up. I haven't turned down, so it's not terribly loud for those of you who are around. What are our steps for finding a inverse? Just generally, what do we do? Yeah, f of x, change f of x to y, switch x and y, and solve for y. This is going to be similar to when we were dealing with logarithms, in that there's going to be a magical factoring step. It is going to be nicer than dealing with logarithms because there are no logarithms. Just algebra, okay? So this isn't in your packet. I do have a practice that goes with it. It's not on your review. It is on the test. All right, so I would maybe save a problem or two. Just put a note for yourself today once we get to the practice, which I think we will easily. Maybe do 1 through 3, and then save 4 and 5 for Monday or Tuesday when you're doing the review. Okay? Here we go. Let's switch x and y. So change f of x to y, because I'm lazy, I'm just going to do it like that. Switch x and y. And solve for y. So a couple of things to be careful about here. One, make sure you're putting the y in both places when you're switching x and y. The other thing, pay really close attention to your signs. Now, we're going to do domain and range with all of these problems after this first one, and domain and range are really good ways to double check your work. I definitely have made sign errors on some of these and fix it by double checking domain and range. What is our relationship with domain and range of inverses? Yeah, they just flip. And so once you find the domain and range of your original, you should be able to just flip them for your inverse, which is nice. Okay, so our first step after we switch x and y, and it's going to be the same for all of these. We're going to get rid of our denominator, clear the denominator by multiplying both sides by it. Okay? So multiply both sides by our denominator. Next, anytime we see parentheses, what do we think we should do? Yeah, distribute, and that's absolutely what we have to do here. It's not really an option. So clear your denominator, distribute. Now we need our y's on one side and our x's on the other. So I'm going to pretty consistently, actually I think with every problem, I've been moving my y's to the left and my constants to or my other terms to the right, because I think that's what you guys kind of were digging when we were doing logarithms. So I'm going to move my 4y this way and my 2x this way. You absolutely don't have to do that in the same step if you don't want to. Totally up to you. I think it's helpful to cross out what is gone. So on the left side, I have xy minus 4y. On the right side, in whatever order you want here, -1 minus 2x. And here's the magic step. How do we need y by itself. So how are we going to separate it out first? Factor it, absolutely. This term has a y, this term has a y. We have them on the same side of the equation on purpose. And that's so that we can solve for y. So we're going to factor out that y. divide both sides by that x minus 4. And you've got your inverse. Ooh, I'm going to label it x to the negative 1. You would probably like it written like this, and I would as well, thinking about in the next problem where we're going to talk about asymptotes and such. So I wanted to do one problem where we just did the algebra. We didn't talk about domain and range, we didn't graph it, just the algebra. On the test, what I'm going to be asking for one of these problems is algebra, domain and range. That's it. You're going to be graphing for me on other problems. So here, just algebra and domain and range. Questions about that first one? Okay. Let's look at one of these kind of from start to finish with the graph. Number 2, we have the whole function there and lots of details to fill in. So this is good review. What's the vertical asymptote here? Vertical asymptote comes from the bottom. Yes, x equals 1. Make sure we're writing them as equations. Our horizontal asymptote, since we're same degree, and honestly, since I wrote these problems new this year, I was trying to keep it kind of simple and keep it so that your domain and range would be pretty predictable. All of these are going to be same degree. So here we have 2 over 1 is our horizontal asymptote. For our domain, we're just excluding our vertical asymptote. So our domain here, I'm going to write it in interval notation, negative infinity to 1 and 1 to infinity. Our range, we're just excluding our horizontal asymptote, negative infinity to 2 and 2 to infinity. I haven't thrown any weird ones in here where you maybe have multiple asymptotes, and so they are multiple vertical asymptotes, so you're crossing your horizontal asymptote. I haven't done anything weird like that. Our x-intercept comes from our numerator. So here, if we set our numerator equal to 0, we get negative 1/2. That's our x-intercept. End behavior, we're always approaching that horizontal asymptote in the end. So our end behavior here, as x approaches negative infinity, y approaches 2. And as x approaches positive infinity, y approaches 2. I haven't pulled my calculator out, but that doesn't mean that you have to do all of this without a calculator at this point. That if you're like, if at this point you're really leaning on your calculator for x-intercepts or y-intercepts or really any piece of this, I'm okay with that as long as you're getting the pieces. All right. Do you want to graph this guy? Let's graph this guy now, speaking of the calculator. And then we'll graph the other one once we have it, the inverse once we have it. So we have, you guys can help me with some nice points, because I just didn't grab my key. So we have I'm going to dot in my vertical asymptote. I only have one graphing problem on the notes and one graphing problem on the practice, because you guys have been graphing continuously for the last 3 days, pretty much. So 2. No matter what, when you're finding this information here, I do want you to be confirming on your calculator. Negative 1/2. I have a y-intercept that's 0, negative 1. Is that what you guys are getting as well? Cool. And on the test, I'm looking for at least 2 points on each side of the asymptote. Another nice point I see here on my calculator table, negative 2, 1. You guys got that one as well. -2, 1. And that kind of gives you the nice turn toward that asymptote. So if those are the 3 that you graph, that's lovely. On the other side of that error at 1, I have a good point at 2, 5. A nice one. Not that the other points aren't good. They're just not whole number points. And 1 at 4, 3. And that is sufficient for our purposes. Make your nice curve. Ready? And now we're going to find the inverse. So I'm going to recopy this guy, set equal to y. And y equals 2x plus 1 over x minus 1. I'm going to switch x and y. And solve for y. So our first step here, after we have our x's and y's switched, is always going to be to clear that denominator. So if writing out steps for this one helps, clear the denominator. Multiply your x in, or distribute your x. Get your y's on one side and your x's on the other. Don't combine unlike terms. That's the dangerous part of like stacking them like this. Don't make it one term because it's definitely multiple terms here. So that's xy minus 2y. What's the magic? I know you're thinking factor out the y. But you're not saying it. Probably because I'm making a video. You're being shy. Alright, once we factor out the y, then we can divide by the x minus 2. Sometimes I get to the end and I'm totally freaked out. But like, how am I going to know if I made a mistake? Because I can't really check this in my calculator. It's not like the rest of this unit where like, if I found an asymptote, I can confirm it with the picture or the table. So what I do here is I write down, and even when I'm not given blanks for it, or even when you're not given blanks for it, I would write down your vertical and horizontal asymptotes. So here, what's our vertical asymptote going to be? Yeah, x equals 2. All right, and what's our horizontal asymptote going to be? It's going to be here at same degree, so it's going to be y equals 1. If those two are flipped from our original, which here, 1, 1, 2, 2, if those are flipped, you're probably golden. The times that I've made like mathematical errors with negatives and stuff, those aren't right, and if those aren't right, then you need to double check it. All right, let's fill in the rest of the details. Our domain of our new function, of our inverse, we're going to be excluding 2. It's kind of color coding, and then I think I lost my color everything. Negative infinity to 2. To infinity. Range, we're going to exclude our horizontal asymptote, negative infinity to 1. Again, that should be flipped from above as well. End behavior is based on our horizontal asymptote here. We are approaching 1. we graph this on top of the original function, it is going to look like a mess. Disclaimer. Actually, the very first problem that I picked to do with you guys, the original function and the inverse were actually the same function. It just happened to be like the perfect one that when you flipped it, it was the same, which was interesting and a little bit frustrating because I had to redo what I was doing. So when we graph this new guy, let's get to graph it and get some new points, x plus 1, x minus 2. Our x-intercept here is nice. Our x-intercept here is going to be -1. All right, let me get this stuff up here. I'm not gonna like the color combinations that I have going on, but we're just gonna have to kind of let's clear it. Okay, so we have vertical asymptote at x equals 2. Horizontal asymptote at x equals 1. Here we had a y-intercept of 0, -1. Now we have an x-intercept of -1, 0. All right, our other nice points. I have 1, -2 as a nice point. We had 2, -1 on the, or, let's see, it was 1, -2. -2, 1 on the other graph. You should be crossing on a line y equals x. I don't want to dot another line in there because, again, this is a mess. I have the point 3, 4. We have the point 4, 3. I have 5, 2. We had 2, 5. Our asymptotes should cross on the line y equals x. Our graphs should cross on the line y equals x. Again, I'm not going to have you graph these, but I wanted you to see this relationship. See that it's working like our logarithms and exponentials did, and our lines, and our quadratics and square roots did as well.